My name is Nicole Hemsoth, and I'm the editor of Datanami, a new publication from the publishers of HPC Wire dedicated to covering big data. So this morning we're joined by Bruce Toal, CEO of Convey Computer. We also have with us Geoffrey Noer, who's Senior Director of Product Marketing at Panasas. And we also have Bjorn Andersson, Director of HPC at BlueArc, which is now part of Hitachi Data Systems. And Addison Snell, CEO of Intersect360 Research.
Thanks, Nicole.
And Addison, I think you have a definition for big data, not maybe necessarily as in general, but how it relates to HPC. Can you explain that a little bit?
Well, sure. As analysts, of course, everybody's got definitions of big data, but in general, what people are looking at is the fact that organizations of all types are dealing with increasing amounts of data, more sources of data, more types of data, and this has given birth to a realm of really important analytics applications for competitive advantage, scientific advancement in enterprise analytics or research analytics, real-time analytics, and things like complex event processing. You've got data mining, visualization. And where there's an opportunity for HPC is that a lot of the technologies that are necessary for doing those types of applications have been nascent in the HPC industry for some time, whether you're talking about dealing with very large files, dealing with many files, dealing with shared access to files, real-time I/O, computation that's fast enough that it's done within the lifespan of the data, which in some cases is very short, or even the long-term archival of large amounts of data and still being able to find it or analyze it later on in a very long lifespan. All of these technologies have been around the HPC community for, in different ways for a long time and have been matured. So really for the HPC technology vendor community, big data represents a new opportunity to go to market with those types of applications, don't you think?
Yeah, definitely. The way we look at it is really, it's about information. So I think about it as big information instead of big data. And underneath that, you have all of the things that we're used to from the HPC side, dealing with the petabyte size data content, dealing with how you get it from point A to point B, how you get it to the end user. But really the breakthrough, I think, is when you talk about it in the terms of information. So it's data with the context.
Right.
So, and when you get to that, I think this wave we're in now with what we call big data can have the same impact as when we sort of got web to be more commonplace.
So from a storage vendor perspective, then that's kind of an interesting take. And you're looking at it like Addison from the application standpoint.
Exactly. Well, really what any of these analytics are trying to achieve is move from having superior data to making superior decisions based on the data.
So from the storage angle, do you have anything to add to that?
I guess so at Panasas, we actually see big data as being a continuation of a phenomenon that really has started a number of years ago. And a lot of it really really comes out of the growth in the number of sensors out there in the world capturing all sorts of data from in all sorts of different verticals. So for us, it actually goes a little bit beyond analytics. We actually see we have 4 Ds that we've used to sort of categorize big data. There's design, which comes in from, for example, large aerospace or automotive manufacturers going through complex simulations to understand how to design their next generation products. We have discover, which covers basically all of the core scientific research types of applications. Then you have decide, which is more of the analytics, the classic analytics of understanding like what a consumer is going to buy next, or analyzing patterns in data. And then the final one is deposit, which really has to do with gathering and scanning or digitizing large volumes of information to then do subsequent analytics or research on.
Right.
And so some of those are problems that have been growing in scope for many, many years. Others have just sort of just gotten to the size and complexity to really be deservedly categorized as big data.
From the systems level then, Convey, how do you respond to some of this discussion on the application level?
Well, I'll pick up on something that Addison said that I think is really true, which is, HPC has long been, where innovation in technology is genesis there. And so I think it's, there's no surprise why all of this excitement around big data in HPC, but as you know, big data has taken on a much broader term. We see it used constantly, and I think it's because of this huge rise in the content on the web and the amount of data that's being captured and needs to be analyzed. So for us, for an example, bioinformatics, we're doing a lot of work with a tremendous amount of gene data that comes in. Times where it used to be a week to process the data, to assemble a gene, we're able to shrink that to a day, and that puts even more pressure on the data systems, as you know. And this is just going to continue to expand out through commercial.
Are you all getting the sense that there is a huge market opportunity that remains untapped in big data for HPC vendors? What do you think the dynamic is right now? Do you feel like this might enable you to reach new customers? Is it changing your approach in terms of technology development or just marketing, outreach?
Well, I'll pick up on that again. It is absolutely a different dimension to HPC. So I think whereas floating point has been, one of those constants over time, the Graph 500 benchmark, I think, is a great example of being able to measure a different aspect of computer performance. Steve Wallach, one of the co-founders of Convey, makes the statement that by the time we get to Exadata, it'll be measured. The way people will measure the success of an Exadata deployment is with the Graph 500 benchmark, which is a bold statement to say data intensive is what's going to be the future of high performance computing.
Yeah, I think over time, sort of the HPC is to some degree about moving the bottleneck. If you look back a few years, all the focus was on the compute side. And I think with Convey, for example, they're starting to solve that part of it. But now it's really, the focus is on data. How do you get the data into the system and out of the system? And when you get to big data, how do you manage just to share sort of volume of data and get the information out of it?
And if you look at the curves, and I'm sure Addison's research will back this up as well, but if you look at the amount of data generated that analysts are predicting for 2020 or some year a little in the future, but not right on top of us, we're totally at the beginning of the generation of these vast volumes of data. So we're seeing big growth now, but it's nothing in comparison to where it's going to be in years to come. And that growth is accelerating faster than Moore's law would predict by a good pace. So this problem is becoming one that is of more and more importance to everyone as time goes by.
Well, and Jeff, you make the right point, right? And we are in the middle of a study on the big data opportunity for HPC vendors, of course, and there's really two halves to that there. The one is, where does the HPC technology apply, which is what Bruce was just talking about before. And there are a lot of these technologies that are mature in the HPC space that you can bring in, but the other important piece of it is that as you approach some of these proximity markets, or especially new types of end users who don't associate with themselves with being an HPC customer, these same solutions need new languages in talking about them. They don't necessarily speak the language of flops and Graph 500. It might be a more systems-based approach, like you're talking about, Bjorn, where you're talking about the life cycle of your data, the business application or the scientific application of analyzing it faster.
You mentioned new application spaces, so fraud detection. Who would think of that as a classical HPC market? But it's using, well, an analyst is always forward-looking, right? That's what I had to say about that.
Thanks, Bruce. I appreciate it.
Got to try anyway. Fraud detection, really a great example. So I think that we're going to continue to. We like to think we're going to make data actionable in real time.
So what are the real-time challenges then from a storage perspective in particular? I think there's some sort of interesting technologies all vying with each other to be the big data technology. So where do you think that the development's going to come from? Who's going to adopt what for these type of HPC looking applications?
To some degree, I think it is sort of going back to physics. Really getting data from point A to point B. So it goes now back to sort of network bandwidth and things like that. And where do you place the compute power in that line or pipeline of what you try to do? In a way, I think big data, the capacity part of that, I think that's the easy part. Mm-hmm. It's 7 or 8 years ago, petabytes stopped being a challenge anymore. It's now about sort of how do you deal with getting the data to where it needs to be and do the compute where it needs to be.
Right. And keeping the immediately needed data right where it needs to be.
Exactly. So having tiered architecture where you can actually sort of automatically move the data where it needs to be.
Real time, which is the core of your question there, is another one of these terms like big data that tends to shift around in meaning a little bit depending on who you're talking to, which can bother an engineer sometimes because real time actually has a specific definition, and usually people aren't using that definition of real time in the engineering sense. So the way I like to think about it is beyond the sense of, people will use real time to vaguely mean it's fast enough to be interactive. I put a slightly stronger definition of real time. A real time application, or real time data, is one in which there's no such thing as an answer that's both late and correct. The timeliness is part of the application. If I get the right answer too slowly, it becomes useless or wrong.
These are all problems that a lot of HPC vendors have already solved for, to suit the needs of financial services applications, for instance. What is really new here for HPC companies that have, like I said, solved a lot of data-intensive computing challenges? For researchers, for, like I said, financial services, I think is a good example. What fundamentally has changed?
One thing is, I guess you look at one of the most simple explanations for what big data is. It's data that's a lot larger than it was a year or two ago, right? And so for each different segment, what that amount is very different, right? So it might be petabytes in a core research environment. For analytics, maybe it's 100 terabytes. It could be a very different amount. Maybe one that wouldn't even be considered particularly big in a different vertical. Right. So we see parallel file system technology coupled with the high-speed networking that is common in HPC, but maybe not so common in the enterprise, as representing a big opportunity. So the changing of the architecture of both at the application level and how you're going to go about solving that problem, that's really at the root of what the big data challenge is, right? How are you? The problem has grown. It kind of doesn't really matter so much where it's grown from and to. It's just growing at a rate that it doesn't fit the existing methodologies, and you need to discover something new. And for analytics, you have the Hadoop file system, for example, which is write once, and then you're analyzing it. And you're bringing the compute basically to the data locally. Exactly. But there's a huge opportunity with parallel file systems and high-speed networking to actually use network storage for that and remove the number of idling computers and actually introduce efficiency. Okay. So there are a lot of interesting applications of HPC technology to even the more enterprise side of the big data challenge.
Okay. Very good.
I would almost compare it with sort of when grid computing suddenly became cloud computing. What happened was really that within HPC we have been doing grid computing, cluster computing for a long, long time. Then we added sort of a web services interface to that, and it became cloud computing.
It evolved from something already existing.
The same thing will happen on the big data side. When we add that layer, so more sort of laymen can actually reach the data and do something with it, you'll get much more collaboration, much more sort of randomness in the data. So I think that will change also the kind of technologies you deploy to actually do big data. So it's no more sort of streamlined applications, just one application doing something. You have multiple users with multiple applications. So it's sort of random by default, and you need to have an architecture that supports that.
So we've kind of hit on the architectures. I think you mentioned a key word there, and that's Hadoop. And one could make the argument that frameworks that are becoming very mature, like Hadoop, I'm sure some of you could argue whether or not it is mature, but a lot of enterprises are adopting it. How does that fit into your strategy, knowing that lots of organizations are adopting very complex big data systems, and these might be folks that never were touched by HPC, like have never worked with a Convey Computer or Panasas.
So as you mentioned in the beginning, we're not part of Hitachi Data Systems. So the benefit of that for us is that we have a really broad technology portfolio. And part of that is an acquisition that happened about a year ago with Parascale into Hitachi Data Systems. And they actually do the Hadoop side of things. Right. So what we can offer is both the sort of parallel file systems, but also the Hadoop way of doing things, coupled with the randomness in terms of doing hardware acceleration of data.
Absolutely.
I think what's maybe still very unexplored with Hadoop and on the analytics side is the question of, developed out of Google with a commodity hardware approach, storing the data locally on local hard drives and making a huge, many thousands of server deployment basically dedicated to Hadoop. That's not necessarily going to be the architecture and the approach that's going to work for all sorts of other businesses whose job isn't full-time to be processing the internet and managing Hadoop workloads, right? So in a mixed environment where you may be running a combination of traditional HPC workloads, and then you also want to do some Hadoop-driven workloads, or if you want a general-purpose compute environment, that may call for a different architecture. And I think exploring that type of direction and watching that over the upcoming years is going to be one of the more interesting aspects.
Great. Addison, you look like you're going to chime in there.
Bruce can go first.
I was going to say, Hadoop, of course, is very a popular topic today. It's a particular solution, but it's not as you mentioned, it's not the end solution for everything. And for example, graph analytics, Hadoop's not particularly well suited for that. Anywhere we've got complex join operations, that's not and there a shared file system ends up being, a better approach to doing that. But having, a compute platform that's kind of tailored for doing this kind of graph analytics, and people say, well, what is graph analytics? Well, the spread of the viral spread of a disease is one example of how you use graph processing to do that. Bioinformatics is another example. We mentioned fraud detection and analytics. So there's a whole range of solutions that aren't, I'm not trying to belittle the popularity and the usefulness of Hadoop, but it's not everything.
Right.
Right, that's very similar to what I was going to say. Hadoop is one specific solution to one specific type of big data. It's certainly an important one for a big category of big data, but it's going to be part of an overall big data strategy, or at least a Hadoop style analytics are going to be part of an overall big data strategy. And I think for you in the vendor community, it's going to be important to incorporate Hadoop into what you're talking about without completely subsuming your entire big data strategy. If you went in and all you talked about was Hadoop, I think it'd miss a big part of the opportunity.
And that is part of the challenge, is that big data as a name of a phenomenon hasn't been defined clearly with consensus from everyone yet. And hopefully this panel and others like it are helping move that in a positive direction. But we very much don't see analytics as being the definition of big data at all.
I don't know what the problem is. As analysts, we put definitions out there that we expect the world to follow. And just got to get everyone in line.
That's right.
While there aren't any clear definitions, I would say that there are at this point. I think the same thing happened with grid and cloud too.
Yeah.
There are keywords that as just words themselves sort of define. And so analytics, certainly real time, no matter how you want to define real time.
Right.
And Hadoop, I think, is increasingly becoming one of those names or words that's synonymous with big data.
Well, one thing I would try to do in order to summarize some of the big data problem is, of course, data is a common theme that runs through a lot of it. And what I think a lot of organizations are coping with is they have these mountains of data in whatever format, whether it's large files or many files or real-time files, but there is a concept of bigness, and what I'd like to do is turn that into something that's actionable. It's similar to what we do with market research data, is you want to not just give our clients a big pivot table, but you want to give guidance, and that's what people are looking for, is guidance out of their data. I don't want to just walk around feeling vaguely smarter and pleased with myself. I'd like to actually make a business decision that's quantifiably better at the end of the day, and that's what big data is about.
One final question for you guys, and I think this one deserves maybe some complex answers from all of you. Like I said, certain words have become synonymous with big data. One of them was Hadoop, like I mentioned. Why isn't HPC sort of synonymous with big data right now, when out of all of the IT communities, really, the HPC community has worked out a lot of problems that are relevant to people looking for big data solutions on the storage system side. So why isn't HPC synonymous? What needs to be fixed? And frankly, how are you going to fix it?
I'm sort of a pragmatic, so I don't put that too much value on the words themselves. So I look at sort of what kind of problem are I trying to solve. And in the HPC community, we've always been on the forefront. We have been pioneering technologies that eventually gets named something in the more mainstream area. Big data is one, cloud is another, the web itself is another. And I think if we focus on solving the problem and really coming up with the technologies that then can move into mainstream, that's sort of the role I see HPC playing here. Because we have sort of moved beyond talking about sort of petabyte being big data. We're beyond that. And we're off to the next problem, basically. And the mainstream will be able to leverage that as we go forward.
Addison, I'm curious what your take here to frame what the other two say from their perspectives.
Right. Well, it comes down partly to the language of people not associating themselves as the HPC type of customer, where they think of that as an academic or research lab kind of thing.
That's the whole problem with HPC right now,
right.
isn't it?
That's a major problem. But if you approach it, in our research, approaching it from the concept of a satisfaction gap, right? How important are these different criteria in trying to solve a problem? How satisfied are you with the available technologies? It provides a roadmap for here are the technologies that we need to bring to market. Here's the language that we need for solving them. And it's not just on the storage side, although that's a huge component, but there's a storage angle, there's a compute angle, there's an interconnects angle, there's a cloud angle. And all of these form complete solutions that just need to be discussed in the context of the problem that the organization in question is trying to solve.
To kind of back up with what Addison said there, I think he made good points to kind of frame that discussion. What do you think, Jeff?
Well, so I also agree that the association of HPC just equaling universities and government workloads, those are important parts of HPC, but that's a lot of the reason why often the words technical computing is used as an alternative term just to try to be more inclusive. But we definitely look at HPC as being a broad definition. And similarly, we think that big data is a similarly broad definition, and there is a lot of overlap. So we look, Panasas was founded around solving the problem of high-performance parallel file system-based storage across the network with over high-speed Ethernet networking, and our direct flow protocol to introduce more parallelism into the communications with storage has now become part of the PNFS standard. So we've been working for a number of years on solving the problems of how do you get vast amounts of data to your compute quickly over the high-speed networks. And we think that's of direct relevance to big data. So big data is where we are today, and it will be where we will be for years to come.
Because you've been in this space for quite a while. All of you have been in the big data business for, how long have you been in business? Right. So Bruce?
So I'm with Bjorn on this. I don't attach much importance to, how does HPC going to get its name out there. I can go into a pharmaceutical or a genetic research, and they don't identify themselves as an HPC account. They just want to get genetics done, and or if you go into a automotive company, sometimes they use HPC tools, but they're there to do crash analysis and structural analysis and fluid dynamics. So I don't really accept that that's part of our challenge is to try to make HPC the word. I think it's great. Technologies flow from HPC, and let's go give the solutions to people that have the money to buy them.
Okay, very good. Addison, as the analyst sitting here, give us your sense of what's going to happen for big data and HPC over the coming years.
Well, I think the vendors that get it right are going to find ways to leverage their technology into growth areas that are either part of or proximal to HPC, just depending on your course of language that you choose.
What are some of the, what do you think some of these new areas are going to be, these emerging application areas? Like he mentioned fraud detection. Do you have any other
Well,
areas?
fraud detection is a big one. Risk management is a big one. You get into a lot of logistics types of applications that involve big data, even things like inventory tracking on an enterprise side. It really can be, though, based on how you analyze the data of, you've got RFID tags on all of your boxes in the country that generate a ton of data, right? And if you're trying to optimize how you're managing inventory on a worldwide scale, that can absolutely become an HPC application that we would file under our high-performance business computing methodology.
And just so Convey, is a play on the, a company called Convex, right? So we all came from that convex background.
You're going to do a Convez by the time you retire, right?
I hope so. That's my goal. But one of the things we ended up finding, a lot of machines being sold into supply chain management because, it's a bunch of nonlinear equations you're trying to solve to optimize the supply chain. Now, would people recognize that as an HPC market? Not necessarily, but the tools are there. The solution was appropriate for that kind of segment.
And similar to that, we sell into areas like video surveillance with face recognition. So the face recognition part of it is definitely an HPC application.
Right.
There's also big data coming from that, and it's real time.
Right. Right. Fellas, this has been a wonderful panel. I look forward to seeing what the future holds for HPC, for big data, and maybe even a change in definition eventually of HPC to match these newer and growing needs. So thank you very much.
Thanks, Nicole.
Thank you.
Thank you.
Thank you.